Hey friends, it's Ian Khan, the Futurist here at the Humanoid Summit. I've got with me Ryan. Ryan, here's Ryan's robotic hands. I really want to ask him about what these hands do and how they do it. Ryan, tell us all about your company.
Yeah.
What you guys make and what's happening with it right now.
Yeah, so my name is Ryan Saavedra. I'm the CEO and founder of Alt-Bionics. We're a bionic hand company that started out in 2020, and our whole goal was to change the game in prosthetics for people and try to make these advanced technologies more affordable for everyone. And so we successfully did that with Genesis, our flagship robotic hand, which is now also used in robotics. But then 2022 comes along and a humanoid company reaches out and says, hey, saw your work in affordable prosthetics, like that's a big need in robotics as well. So then we moved on to robotic applications.
Very cool.
And so, yeah, it's been a whirlwind of a journey, but now we are in both markets and we are selling across the world to huge names in the robotics and prosthetics industries.
So you're in production, you're selling the product.
Yeah.
You're no longer just experimenting.
No more experimentation. Yeah, we have more plans for future hands, but
always.
Yeah.
But tell us about the product. What is it that you exactly do?
Yeah, so we build bionic hands. These are 6-degree freedom hands. They can do about 60% of all human level tasks, and that's something that we internally verify and validate.
How much degrees of freedom do we have?
We have 27, depending on if you look at the wrist or not.
27.
Yep.
And so that's your movements, right?
Yeah.
This is it?
Everything. I mean, I always tell people to imagine like putting your hand out the car window and like making these like crazy wave movements. Like that's a really good representation of the utilization of almost all of our degrees of freedom within our fingers, except splay, of course, or abduction, adduction. But yeah, there's tons. And the big challenge in all of robotics and why everyone says hands are like the biggest issue is because everyone's trying to replicate the human anatomy, which I don't think is a very good idea, just given that technology is nowhere near the power density and I guess just the technical advanced level of our human anatomy, right?
Yeah.
And so,
so here you go, you're innovating the hand, the prosthetic hand. Tell us about it. So you've got what, 6 degrees you said?
6 degrees of freedom, 10 total degrees. And then we have nails, we have very specially developed rubber on the fingertips that allows really good contact. So high coefficient of friction, but also just enough to have like a little bit of a human feel to it. And then 40-pound lift capacity, we have a 400 millisecond closing speed, and then we obviously have teleoperation via Manus. And so we have confirmed that this can be controlled from Seattle all the way to India with sub-second latency.
Oh, wow.
And so think about like Casevax for military application, hazardous waste removal from nuclear facilities, things like that. Like those are the applications, and like the more extreme conditions. But today they're being used in agriculture, they're being used in culinary environments, so like food prep or like, yeah, just tons of different things. Yeah.
Yeah, wow. What are you seeing in terms of who wants this hand more? Is it who is it? Is it healthcare industry? Is it, I don't know, manufacturing? Where are you supplying most? Yeah,
so right now it's about a 60-40 split between prosthetics and robotics, with prosthetics being the bigger sales avenue right now. And then in the future, though, it could very well pick up to be a majority robotics, like 90-10 to robotics.
So when you talk about prosthetics, how is this being controlled?
Yeah, so that is based off of electromyographic signals. So anytime you move any muscle in your body, your brain sends a very small electrical signal. And we pick that up and we can say, oh, I see that. And then we boost it to 0 to 5 volts and say, I recognize what to do if I break a 2.5 volt threshold.
Yeah.
And so it's a very simple process. Like it sounds complex, but really it's just, I put a surface electrode on your skin, I find the best point of musculature, and then I can allow you to control this. Like I have kids up and running with this and like picking items up in like 5 minutes.
Yeah, so let's say I've lost my hand in an accident. I don't have a hand anymore.
Yep.
So we've retrofit this somehow. It fits in here.
Yes.
And it's connected with it's battery operated?
Yeah.
Okay, so there would be a cable running through, there'll be a battery bag. Great. Now, when I'm doing this the first time, now we're getting into the training part of it. We connect. How do you build those neural connections of being able to control it or make movement in it, right? The body-brain training, how does that happen?
Yeah, it's the same way as you learn any other new skill. It's just practice. Like you learn how to do it, you make the connections, and then it's just repeating those connections over and over. Like I had to relearn what to do, because if you lose your hand, you still have the muscles that control your hand.
So that's what muscles still here, right?
Yeah, and so these movements back in college with our first prototype, like this would equate to moving into like a pinch grip, or this would equate to moving into like a power grip. And so just different movements are responsible for going into different grip patterns, and then it's just training that. Some people are up and running, like amputees are up and running with this in 10 minutes. Like people just put this on and know what to do with it.
Oh, really?
Yeah.
Wow.
And so we've seen it as fast as 10 minutes, but sometimes up to a couple weeks.
Yeah.
It just depends.
So this is a game changer. You know, you've got folks whose feet are not there, or legs is missing, or arm or leg. There's many different cases of it being used as a prosthetic. So that changes the healthcare industry a lot, where that need arises.
Yeah.
So that's incredible.
And two of the most important things about our hand is that all the things are modular. So in the event that you do break a finger, or one accidentally it gets damaged or it reaches its end of life, in about 30 seconds, I remove all these screws, I can take individual finger modules out, put them back in. So now the typical repair process can take weeks for some people, but beyond that, and more importantly for me, these are the most affordable hands in the world for amputees.
Yeah.
So by like a factor of, I think it's like 2 already, so 50% less than the least expensive alternative out there.
Yeah.
But
yeah,
between those two things, those are like the biggest value adds for us.
Very incredible. What about battery life? It lasts for a while? Or?
Yeah, about 18 hours with ours, using a 2200 milliamp hour battery at 8.4 volts.
Okay, good. Military applications, there's obviously, you could fit this on, I don't know, a robot dog or something, and then it could go and do finer things that the clamp is not doing. Now the hand can do it. Right? I don't know. I'm just coming up with some
done tons of applications. So we've heard back from the Army, the Air Force, and the Navy about different applications for these hands. So they want to put these like in the hulls of ships where people would originally go and like maneuver levers or valves or push buttons in the base, but you want to remove those people from those areas, especially during like wartime operations, when if they get hit, you want to seal those sections off, right? Now you're sealing off a humanoid and not an actual human.
Yeah.
So tons of applications across the entire military.
Interesting. Would these hands operate on their own if they had their own battery power and it would do things
on
its own?
Yeah.
Right?
So in our future, we're planning to make our own VLA model that will be basically compatible with all VLA models. So think of it as like a cap for your existing full body VLA for your humanoid robot.
Yeah.
And so now you just take our open source VLA, plug it into yours, and our hands know what to do based on what it sees and what it can feel. So we have a version of this that has tactile sensing so it can feel objects. And so with all of that data, then you can then make the assumption, or the robot can make the assumption for itself of what it needs to do.
Yeah, I'm just thinking about some applications, and it's like, I think, what is it? Is it the Addams Family that has the hand?
Yeah,
right?
we were actually on Netflix's Wednesday red carpet premiere. So our hand thing, our thing was being controlled by our hand. And so all that walking and...
So inside was yours?
Yeah.
Oh, wow. Yeah. Oh my God, that's so cool.
It's fun,
So it could just be doing that. I'm thinking now, you've got maybe applications where they're far. I don't know. I need to turn a knob on top of my submarine like it's 60 feet up. I don't want to send a person. Or there's something needs to be tightened or unscrewed way inside a crevasse somewhere. You could send in the hand, right? Could retrofit it with a camera. I don't know.
Yeah,
possibilities are endless.
Yeah, especially as we go to higher degrees of freedom where you can actually replicate the movements of thing.
Yeah.
Like if it could walk on its own, like sure, nothing would prevent it from not doing that.
Incredible. I love it. I think it's really a game changer in robotics and mobility and control, which we haven't seen before. So good luck with building and growing the company. And this is incredible.
Thank you. Can I shake your hand?
Yeah, of course. There you go. Cheers. All right. Thanks so much.
Thank you.